Hi students, 12th standard chemistry, unit 5, coordination chemistry. Okay, so in this session I am going to teach you the example for valence bond theory. Okay, already we are seeing the example and this is the fifth example. Okay, this is the coordination complex that I have taken here. Okay, first step I have to find out the atomic number of the central metal atom. Okay, here Gopalt is the central metal atom. So, the atomic number of Gopalt is 27. What is the atomic number of Gopalt? 27. Okay. In this way we have to do that. Then the next one, oxidation state. Okay. I have to find out the oxidation state for the central metal atom. What is our complex? Our complex is COCl4 2 minus. Okay, this is our complex. Okay, so for this I am going to find out the oxidation state. Okay, here our central metal atom is Gopalt. Okay, I am going to keep the Gopalt as X plus 4 into the oxidation number of chlorine is minus 1 equal to, here 2 minus is there. So, I am writing minus 2. So, X minus 4 equal to minus 2, X equal to plus 4 minus 2. So, X is equal to plus 2. Okay. What is the oxidation state of the central metal atom? The oxidation state of the central metal atom is plus 2. Okay. We have find out the oxidation state of the central metal atom. And then the third step, I have to write the electronic configuration of the central metal atom. Okay, for that you should know the atomic number first, then only you can write the electronic configuration. Okay, so if I write the electronic configuration, how I will write? So you know how to write the electronic configuration. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d7. Okay, if I add the number I will get the value of 27. In this way you have to write the electronic configuration. Then we have to see the outermost electronic configuration. What you have to see? You have to see the outermost electronic configuration. Okay, we have find out the oxidation state. Gopalt is in plus 3 oxidation state. For that I am writing the outermost electronic configuration 4s2 3d7. Okay. So, if it is plus 3 means I have to remove 3 electrons from the outer electronic configuration. If it is plus 3 means what I have to do? I have to remove 3 electron from the outermost electronic configuration. So, let me rearrange and write 3d7 4s2. Why I am writing like this means to remove the electron from the s orbital is easy when compared to the d orbital, and it is also a simple orbital. So, I am going to remove 3 electrons from here, 2 electrons from the s orbital and 1 electron from the d orbital. I will have 3d6 and 4s0. So, let me write here 3d6 4s0. This is our outer electronic configuration for Gopalt 3 ion. Okay. Then I have to write the outer orbital of metal. What I have to write? Outer orbital of metal. Already you know d orbital is having 5 degeneracy set, 1, 2, 3, 4 and 5, and s orbital is having 1 degeneracy set and p orbital is having 3 degeneracy set. Okay. So, this is 3d orbital and this is 4s orbital, this is 4p orbital. Already we have find out the outer electronic configuration. Okay, 3d6. So, I am going to fill the electrons according to the half-up principle. What is half-up principle? Pairing will not take place until all the available orbital is filled first. Okay, then only the pairing is taking place. 6 electrons are present. So let me fill the electrons like this. 1, 2, 3, 4, 5, then 6. Okay. Each orbital is filled first, then only the pairing is taking place. Okay. I have filled the electrons in the d orbital. Okay. Then I have to see what is ligand. Okay. The nature of the ligand I should see. Okay. What is the ligand here? The ligand is chlorine. Okay. Here I have to write the fifth step, nature of the ligand. So in our complex, what is the ligand that we are having? We are having chlorine as a ligand. Chlorine is the weak field ligand. Chlorine is the weak field ligand. Okay, what is the role of the weak field ligand? If it is a strong field ligand, the electrons will pair up. If it is a weak field ligand, it will be as it is. There is no pairing is taking place. Okay, since our complex containing weak field ligand, there is no changes. It will be written as it is. Is it clear for everyone? Yes. And then the next step, I have to write the outer orbital of central metal atom in the presence of ligand. Okay. So I am having chlorine as a ligand, and I am having how many ligands? I am having 4 ligands. Okay. So since this weak field ligand, what is the role of the weak field ligand? Already you know that if it is a weak field ligand, there is no pairing. Okay. So let me write the outer orbital of central metal atom. D orbital is having 5 degeneracy set, and S orbital is having 1 degeneracy set, and P orbital is having 3 degeneracy set. Okay, degeneracy set which is nothing but the orbital is having the same energy. The orbital is having the same energy. Okay, so since it is a weak field ligand, it will be written as it is. So 1 electron, 2, 3, 4, 5, 6. This is 3d6. Then I have to write 4s and 4p. In 4s, 4p, there is no electron. Okay, in this case, what will happen? The ligands will donate a pair of electrons to the central metal atom. The ligand will donate a pair of electron to the central metal atom. Then the bonding is coordinate covalent bonding is taking place between the metal and the ligand. Okay, so in this way the bonding is taking place. Which is the donor atom here? The ligand is a donor atom here. Okay, I am going to write the hybridized orbital now. Okay, so this is d orbital. I am writing as it is. Since it is a weak field ligand, there is no changes in this. Then I am writing 4s and 4p orbital. Here what will happen? This is 4s orbital and this is 4p orbital. What is hybridization? Hybridization, which is nothing but the mixing of atomic orbitals of same energy. The mixing of atomic orbitals of same energy. Here s orbital is going to mix with the p orbital. Since we are having only 4 ligands, I need only 4 degeneracy box. Okay, so I am having the 4 degeneracy box here. Okay, so 1 chlorine will donate a pair of electrons towards the s orbital, and remaining 3 chlorines will donate a pair of electrons to the p orbital. Okay, if they are donating the pair of electron, mean how can I represent? I can represent like this. Okay, this is one pair of electron and this is also a pair of electron. Okay, so in this way the hybridization is taking place. Okay, if I am writing the hybridized orbital, means I will mingle first. Okay, okay, all the Cl, we are having 4 Cl ions. This Cl will donate a pair of electron. This Cl everything is donate a pair of electron in order to form a coordinate covalent bond between the metal and the ligand. Okay. So, this hybridization is called 1s orbital and remaining p3 orbital. Okay. We are having p1, p2, p3. So, I am writing sp3 orbital. Okay. What is the coordination number here? Coordination number, which is nothing but how many number of ligands which is attached to the central metal atom. You see the complex, only 4 ligands are attached. So, what is the coordination number? The coordination number will be 4. Then what is the hybridization? If the coordination number is 4, already we have find out the hybridization. Okay. What is the hybridization? sp3 hybridization. Okay. What is the hybridization? sp3 hybridization. The next step we have to go for the geometry. Okay. If the complex is having the sp3 hybridization means what will be the geometry? The geometry will be tetrahedral. So, this complex is having the tetrahedral geometry. Okay. Then we can go for the magnetic property. What is magnetic property? Magnetic properties explains about the paramagnetism and diamagnetism. What is paramagnetism? If the complex is having the unpaired electron means that is called paramagnetism. If the complex is having no unpaired electrons means that is called diamagnetism. See our complex contain 4 unpaired electrons. How many unpaired electrons? 4 unpaired electrons. So, this comes under paramagnetism. So, how many unpaired electrons there? 4 unpaired electrons. So, this complex exhibits paramagnetism, or this complex paramagnetic in nature. Then the last one, magnetic moment. I have to find out the magnetic moment. How to find out the magnetic moment? By using the formula mu is equal to square root of n into n plus 2. Okay. Here n which represent the number of unpaired electron in a complex. In our complex 4 unpaired electrons are here. 1, 2, 3, 4. We are having 4 unpaired electrons. So, 4 into 4 plus 2. If I do the simple calculation, I will get 3.88 Bohr magneton. Okay. Hope it is clear to everyone. Thank you.